These video notes are going to first review what we already know about slope, and then I'm going to teach you how to find slope when you're just given 2 points and you're not actually given the graph. There's a formula you can use to make it a little bit more efficient. And also, this is like the third time I'm trying this video because I keep messing up so badly that I can't fix my mistakes. So the third time's a charm, right? Okay, so first just to review what we already know about slope. M is the variable that we use to represent slope. And just like what we were doing earlier, slope is rise over run. And then when we were doing tables earlier this year, we talked about the change in y over the change in x. So instead of actually writing that out in words, the little triangle is your symbol for change. So change in y, change in x. So first, we're just going to review what it looks like on a graph. So I'm going to count my rise over run. So if I start at this first point, I'm going to go down. So that would be a negative, and over 1, 2, 3, over 3. So that would be negative 1/3. Or if I saw it the other way, I could count, I could start at the second point and go up 1. That would be positive, but I'm going backwards 3, so that's a negative. Or you can just write the negative out in front of the fraction. So all three of those are the same answer. You can have the negative with the 1, with the 3, or just out in front of the fraction. And then just some other reminders about slope. That capital N, the middle, lets you know that that's a negative slope. Or if you write your name on the line, my name is going down, and so it's a negative slope. So number 2 would be a positive slope. It's going up. And if I wrote my name on it, my name would be going in an up direction. So I'm just going to start at the bottom point. I'm going to rise 1, 2, 3, and run 1. So I can write 3 over 1, or that's just a slope of 3. So you're going to pause the video and try 3 and 4. Here's your answers for 3 and 4. So 3 is a negative slope, so it's negative 3/2, and 4 is a positive slope, and it's 3/2. So now we're going to move into the new material. The new material is going to be, I'm not going to give you a graph, I'm going to give you 2 points that the line travels through. And so we're going to have a new formula to use, which is this. So most of the time you're just going to see m equals, this is y sub 2 minus y sub 1, and then it's over x sub 2 minus x sub 1. So to first of all help you remember that the y should be on the top, it's rise over run. And so rising is going up and down, and that's the y-axis. And running is side to side, and that's the x-axis. So that's why our x's are at the bottom this time. So we saw these sub-numbers when we were doing the area of a trapezoid, and the sub-numbers just let you know that this y and this y come from different places. So you're going to be pulling y's from 2 different points. And the same thing, this x and that x come from 2 different places. So the sub-numbers, once we plug in values, those just disappear. All right, so we're going to look at our first examples, which are 5 and 6. So I have the formula at the top, and then I'm also going to show you how the graphing calculator makes this a little bit easier for you if you want to not always be using mental math. I don't know. I just use the mental math. So I've given you 2 points, and so I'm going to label them. This is point 1. Oops, that's not a 1. That's a point 1, and this is a point 2. So you have 2 points. And then you also have to remember that when I give you ordered pairs, it's telling you what x and y value. So it's giving you the x coordinate and the y coordinate. So now we're going to use the formula. So y sub 2, I need the y value from point 2. So I'm going to go to point 2, and I need the y value. So that would be 4. Let me use a different color so you can actually see it. That would be 4. And then the formula has a subtraction sign. Y sub 1. I'm going to go to point 1 and get the y value, which would be 8. So all I'm doing is just plugging these numbers in the formula. I'm not actually doing any math yet. X sub 2 would be the X value from point 2. So I'm going to go to my point 2. X value is negative 3. The formula has a subtraction sign. And then X sub 1 is going to point 1, and we need the X value, which is 6. So now I'm just going to do the math. On the top, 4 minus 8 is negative 4. Negative 3 minus 6 is negative 9. So 4/9 does not divide evenly, and it doesn't reduce, except for I do have double negatives, which gives me a positive. So if I were to graph that line, I would have to go up 4, rise 4, and I would run 9. All right, so we're going to look at number 6. I don't know why sometimes my marker goes really fast and then sometimes it doesn't. I'm just not even going to try. Okay, so I'm just going to show you a different look. So some students, because the y sub 2 and the x sub 2 come first in the formula, they like to say that point 2 comes first and point 1 comes second. And then they're just kind of always going from left to right. It doesn't really matter how you want to look at that, as long as you're consistent and you don't change. Once you pick this as point 2, you don't try to change it to point 1 halfway through your problem. So y sub 2, I'm going to go, hold on, these are all x and y values. I'm going to go to point 2 and get the right y value. So for this one, that's going to be a 2. Y sub 1 going to point 1, grabbing the y value, which is 6. X sub 2, I'm going to point 2 and getting the x value. And then x sub 1, I'm going to point 1 and getting the x value. So this is going to give me negative 4 over negative 9, just like the other one, and that's going to be 4/9. So if we were to graph both of these lines on a graph, they would have the same exact slope, but they would be in different locations. Okay, so I'm going to show you what this looks like in Desmos. So I'm going to actually I'm going to go to Desmos and I'm going to type this in. First, I got to clear that. Oops. Okay, so this is a graphing calculator, which you should definitely get used to using because this is what you're going to use next year in algebra. If you go down to the little keyboard part, it doesn't actually have a fraction on it like the scientific calculator does. So what I do is I just hit the division key and it creates that fraction for you. Or you can hit the division key on your actual keyboard. So I'm going to do at the top 4 minus 8. And then at the bottom, it was negative 3 minus 6. So this was number 1. And it gives you this long decimal. And if you come over to here, there's a circle with a box in it that changes things back from a decimal to a fraction. So I can just click on that and it creates the fraction for me. Or I can click on it again and it gives me the decimal. So that's kind of an easy way Desmos will do the slope formula for you, so you don't actually have to do any of the mental math. All right, so we're going to try, whoops. Sorry, I got to go to previous. All right, so we're going to do 7 and 8 a little quicker this time. I always do point 1 first and point 2 second, but that's just because that's the way that I learned to do this so many years ago. And when you start doing something for so many years, it's just really hard to break that habit. So y sub 2. And again, I'm doing all this extra stuff that you don't have to do because I'm just trying to be thorough and make sure you see all the pieces. So I'm going to do the y value from point 2 minus the y value from point 1. So a lot of times I just go like this. So that's going to be 16 minus 10. And then I need to do the same thing with the x's. So I'm going to start with x sub 2 and subtract x sub 2, subtract x sub 1. So on the top, 16 minus 10 is 6. If you're using Desmos, you actually have to do negative 11. And then minus, and then hit a minus key again, so you actually have 2 minus signs directly next to each other. Or what you could also remember is when you have minus a negative, that becomes plus a positive. Double negatives give you a positive. So negative 11 plus 9 is going to give me negative 2. And then 6 divided by negative 2 actually does divide evenly this time. That is negative 3. Okay, let's get number 8 done. So here's my point 1. Here's my point 2. So I'm going to do the y's. 4 minus 5. And I'm going from right to left. So that means I need to go from right to left and do 7 minus 10. So 4 minus 5 is negative 1. 7 minus 10 is negative 3. 1 over 3 does not divide evenly, but I have double negative, so it gives me 1/3. And again, if you're using decimals, it just automatically gives you 1/3. The biggest mistake students make is they put the x's at the top instead of at the bottom. And sometimes if students did, like on the top, they did 4 minus 5, which is fine, but then they do it the other way and they do 10 minus 7 on the bottom. So you just have to be careful. Keep your patterns, whatever direction you're going in. All right, you guys are going to pause and try 9 and 10. So here are the answers for 9 and 10, and I did it both ways for you. So I did it where first this was point 1, and this was point 2, so that was this top example. And then I did it the other way where this was point 2 and this was point 1, and that was the bottom example. And you can see you get the same final answer, but what it does, what that formula does when you switch the point 1 and 2 is the first one, the 6 was negative, but in the other one I did, the 4 was negative. So it just changes your signs, but then in the long run, if it changes the sign of both the top and the bottom, then it gives you the same exact answer. I am going to show you really quick what that minus and negative looks like. So I'm going to type this first one into Desmos for you, just so again we can see what that looks like. Oh, I think I've opened up like 5 tabs of Desmos. All right, so I'm going to start with division. And I'm going to do negative 4 minus 2. And then on the bottom, it's 1 minus a negative 3. And so that's what it looks like if you don't change it to plus a positive. And then I can, again, hit my fraction key, and it gives me the fraction answer. So I hope this was helpful. Tomorrow we're going to use this formula again, but we're going to talk about what happens if we don't have a positive or a negative slope. What happens if we have a 0 or undefined slope? So, and what's that going to look like in the equation? So, what will that look like in Desmos too? So stay safe, stay healthy, and practice your math.